Volume of Revolution, the Torus. Welcome to another episode of Volume of Revolution. Today's episode is focused on how to find the volume of a donut-shaped solid, also known as a torus mathematically. In the case of the donut I used for this problem, the solid was generated by rotating a circle of radius 1.25 centered at 2.25, 0 about the y-axis. In this diagram provided by Texas A&M, we can see that rotating a circle around the y-axis can generate a solid known as a torus, which is the solid we will use to find the volume of our donut. The first step is to find the equation of the circle that would be rotated around the y-axis. Now, the 2.25 in this equation is the center of the circle, the x-coordinate of the center of the circle. The 1.25 is the radius of the circle. Now, when this equation is solved for x, we find a result that will lead to the equation of the large radius and the small radius of the washer. The large radius of the washer squared times pi minus the small radius of the washer squared times pi will give you the area of the washer. Now, when this washer is multiplied by dy, you gain one volume of one washer of the torus. Now here I have a diagram that will help you visualize what is going on with this torus. So, as previously mentioned, when you subtract the inner radius which is given by this equation, from the outer radius, which is given by this equation, you get a sort of line that is part of the washer that when rotated around the y-axis will give you the volume of one of the parts of the torus. And when you add all these parts on the interval from negative 1.25 to 1.25, you get the total volume of the torus. Now again, this diagram provided by Texas A&M will help you visualize what is going on with the situation. Now, I'd like you to think of this as one part of the torus, one washer of the torus. And we already discussed that the area of one washer of the torus is really found when you subtract the small radius squared times pi from the large radius squared times pi. And once you have the area, and you multiply it by dy, which is right there, you gain the total volume of one of the parts of the torus, which is right there. And really when you add all these parts together on the interval negative 1.25 to 1.25, you gain the total volume of the torus, or at least a pretty good approximation. Now here you can see this is one part of the torus, this is another part of the torus, and as you keep adding these and so on and on, you finally start to see the full picture of one torus. And so really in the next few parts of the video, I will show you the equations required to really find this integration problem. To get a better real-life picture of the situation, you can pause the video and take a look. So let's recap a bit. We already discussed how to find the area of one of the parts of the torus, that when multiplied by dy you get the volume of one of the parts of the torus. And really that's what the first equation on this part of the video is. It's the volume of one of the parts of the torus, that when integrated from negative 1.25 to 1.25 you gain the full picture of the torus because you get all the parts. And so really the most important equation is the last equation, which is already simplified, and it's one of the parts of the torus integrated from negative 1.25 to 1.25, which gives you the sum of all parts. Now here is how to integrate the last equation from the last slide, and what this will give you is the final volume of the donut of this problem, and this volume was found out to be 69.55486. The math was a bit tricky because it was calculus 2 and used trigonometric substitution, but really when you get the result you get a pretty good estimate that is not perfect because some donuts have irregularities and the volume might be a bit less or a bit more. The first people to make this sort of modern donut were the Dutch, since they took balls of dough and fried them in pork fat, calling them oil cakes. Later, Dutch immigrants that moved to New York brought the oil cake, which became popular in America. The only problem was that this oil cake had no hole, and so the exterior would be cooked before the gooey interior. Now, where did the hole of the donut come from? People attribute this to the Dutch sailor Captain Hansen Gregory, who had his mother make him some donuts for a journey. When a storm hit, he was distressed and needed his hands to be free on the steering wheel, and so he had to place one of the donuts on one of the spokes of the steering wheel, and so the spoke poked a hole through the donut. Since Captain Hansen Gregory liked the donut without the raw part in the center, the donut hole was born. Moving on to a more modern time, during World War I, Salvation Army workers known as donut girls would try and distribute donuts to American soldiers in France, and the soldiers that received these donuts were called doughboys. Now later, these donut girls were replaced in World War II by donut dollies. Later on, speaking of the invention of the donut machine, a Jewish refugee named Adolf Levitt in America created the first automated donut machine in 1920, and he really showcased this machine in the Chicago World Fair of 1934. Nowadays, the two major donut companies are Krispy Kreme and Dunkin' Donuts. As for example, there are more than 5,000 Dunkin' Donut shops in about 40 outlets in nearly 40 countries, and serving 2 million customers a day.